Our final objective for this standard is writing a polynomial function just given the roots. Now, with this polynomial function, we need to recall back all the way at the beginning when we learned about factoring that if I have I as one of my roots, then I have to have another I to balance it out with an even number. Now that other I is going to be a specific I. It's going to be the complex conjugate. So we'll see that as we move through with number 2, 3, and 4. But let's start off with one that doesn't have any I's in its answer. Number 1, we have x equals 4, x equals -1, and x equals 6. We need to be able to write these as factors first. To write them as a factor, you have to move the number to be the same side as the x. So we'll subtract 4 from both sides, and that'll give us x minus 4 as a factor. We'll add 1 to both sides, and that will give us x plus 1 as a factor. And then we will subtract 6 from both sides. That will give us x minus 6 as a factor. Next, you are going to just multiply. That's partly why we did that first polynomial operations standard, because we practiced multiplying. So I'm going to multiply the first two factors together, x minus 4, x plus 1, and I get x squared minus 4x, 1x, and -4. Those combined together give me x squared, -4x plus 1x gives me -3x, and then -4. You're going to take that answer and now multiply it with the final factor, x minus 6. So that gives us x cubed, -6x squared, -3x and x gives me -3x squared, -3x and -6, 18x. X and -4, -4x, and -4, -6, 24. Combine like terms and you have your polynomial. So x to the third minus 9x squared when I combine these two. And then I can combine these two together and get positive 14x and positive 24 equals 0. Now, in the other ones, we have an I in there. The process remains the same. It just looks a little trickier with the I, and we need to make sure that we've included all of the different I's because we should always have an even number. In this case, I was given -3i as a root. That means that its conjugate, positive 3i, is also a root. The rest of it remains basically the same. We take x equals -2, x equals 5, x equals -3i, and x equals positive 3i. And we need to rewrite them so that x is on the same side as the number. So we'll add 2 to both sides, x plus 2. That's a factor. We'll subtract 5 from both sides. X minus 5 is a factor. Add 3i to both sides. X plus 3i is a factor. Subtract 3i from both sides. And x minus 3i is a factor. Now, here's where I tend to ask you to do things a little differently. Instead of just starting at the beginning and multiplying, I ask that you multiply the two factors that have i's together because that will get rid of I in your answer. So we're going to multiply these two together first, x plus 3i and x minus 3i. x times x, x squared. X times 3i, 3xi. X times negative 3i, negative 3xi. And then 3i times negative 3i is negative 9i squared. We know that I squared always equals negative 1, so really this equals positive 9. So that factor is actually x squared. These guys cancel out, plus 9. I would next recommend that you multiply the other binomials together. I would do as much multiplying of binomials as I could before I had to enter into any other kind of exponents, because I think that students make more mistakes with exponents. So x times x gives me x squared, negative 5x, 2x, and negative 10. Combine those together, and we get x squared. These two combine together to be negative 3x and negative 10. And the last multiplication we'll have to do is to multiply it by our x squared plus 9. Now you started with 4 different factors. That means that your degree should be 4 in the end, because remember 4 solutions had a degree of 4. So x squared and x squared, x to the 4th. There it is. X squared and 9, 9x squared. Negative 3x and x squared, negative 3x cubed. Negative 3x and 9, negative 27x. X squared and negative 10, negative 10x squared. Negative 10 and 9, negative 90. X to the 4th, it's the only one that has an x to the 4th. X squared here and here, so that will combine to be negative 1x squared. We also had an x cubed we probably should have written in there first, so I'll write him in there. Negative 3x cubed, and then our negative x squared. Then we had negative 27x and negative 90. There's my polynomial. Let's do 2 more. Number 3. So for number 3, I have something with an I. So if 4 plus I is a factor, then 4 minus I also has to be a factor. So I have x equals negative 4. I know that x equals 4 plus I, and x equals 4 minus I. We got to move everything onto the same side with the x. So that means adding 4 to both sides here. X plus 4. And here it means subtracting 4 from both sides and subtracting I from both sides. So x minus 4 minus I is my next factor. I'll just bring down my x plus 4 so that it's on the same row. And we'll subtract 4 again from both sides. And this time we'll have to add I to both sides. So x minus 4 plus I is my last factor. Again, multiply your i's together first. So I know that that means a trinomial times a trinomial, but we want to get rid of those i's as fast as possible. So we have x minus 4 plus I and x minus 4 minus I. X times x, x squared. X times negative 4, negative 4x. X times I, xi. X times negative 4, negative 4x. Negative 4 and negative 4, positive 16, negative 4 and I, negative 4I. Negative I and x, negative xi. Negative I and negative 4, positive 4I. And then we have negative I and positive I, and that gives me negative I squared. I squared always equals negative 1, so that means that we have negative negative 1 or positive 1. Let's combine our like terms. X squared is the only x squared term. Negative 4x minus 4x is negative 8x. 16 and 1 can combine together to be 17. Negative xi, positive xi, those cancel. Negative 4i, positive 4i, those cancel. So the only thing left to do is to multiply by 4x plus 4. X squared times x is x cubed. X squared times 4, 4x squared. Negative 8x times x, negative 8x squared. Negative 8x times 4, negative 32x. X times 17, 17x. And then we have 17 times 4, which is 68. So my final answer, x cubed. These two combine together to be negative 4x squared. Negative 32 plus 17 combines together to be negative 15x, and then a positive 68. Oops, I forgot to make my number 2 equal to 0, but it should be equal to 0 because we are writing an equation or a function. So you might want to go back and change that to equal 0. Don't want to study off of something that's wrong. Last one. So we have 6 minus 2i as a solution. So that means that I have to include 6 plus 2i as well. X equals 6 minus 2i. X equals 3. And x equals 6 plus 2i. We'll subtract 6 from both sides. X minus 6 equals negative 2i. We'll add 2i to both sides. That gives me x minus 6 plus 2i as a factor. We'll subtract 3 from both sides. So x minus 3 is a factor. And finally, subtract 6 from both sides. And I get x minus 6 equals 2i. We'll subtract 2i from both sides. And x minus 6 minus 2i is my last factor. Multiply your two factors that have I in them. So x minus 6 plus 2i and x minus 6 minus 2i. X times x, x squared. X times negative 6 is negative 6x. X times negative 2i gives me negative 2xi. Negative 6 times x is negative 6x. Negative 6 times negative 6, positive 36. Negative 6 and negative 2i gives me positive 12i. X times 2i, 2xi. 2i times negative 6, negative 12i. And finally, 2i times negative 2i gives me negative 4i squared. I squared always equals negative 1. So it's really a positive 4 in that box. So our factors together give me x squared. Negative 6x and negative 6x gives me negative 12x. 2xi and negative 2xi, those cancel. 36 and 4 is 40. 12i and negative 12i cancel. So the only thing left to do is to multiply by my x minus 3. Sorry, there's a weird 5 in there. X times x squared is x cubed. X squared times negative 3, negative 3x squared. X times negative 12x, negative 12x squared. Negative 12x times negative 3 gives me positive 36x. 40 times x gives me 40x. And 40 times negative 3 is negative 120. Combine our like terms. X cubed, negative 3x squared minus 12x squared gives me negative 15x squared. 36x plus 40x gives me a whopping 76x minus 120 equals 0.